Okay, so they give us a function. They ask us to find the domain of this function. Well, this is a fraction, and the only violation we could imagine here would be if we had a 0 on the bottom of the fraction. A 0 denominator is not allowed. So we will find all the x's that make the denominator equal 0, and we will eliminate those. So set the denominator equal to 0 and solve. We get a second degree equation. So let's go ahead and solve this second degree equation. We'll do it by factor by guessing. Equals 0. X is in the first position. And we have a positive 1 and negative 2. You can test that and see first times first, last times last, product of the outers plus product of the inners. Good factory. Now, since it's equal to 0, we use the 0 product property. Set each of the factors equal to 0 and solve. We get x equal negative 1 for this contribution of this factor, and the other 0 we find is x equal positive 2 when we set the second factor equal to 0. Okay, so I'm going to union these together. These guys are the ones that we want to exclude from the domain. They're not allowed in the domain because they're the values of x that make the denominator 0. So we can write our answer. The domain in set notation is equal to curly set bracket, all real numbers x, such that x cannot be equal to negative 1, comma, x cannot be equal to 2. Those are the two restrictions on our domain. We'll go ahead and box those. So that is set notation. Now, if they wanted graph notation, we would draw the graph excluding just these 2 points. So here's our x-axis. Here is negative 1. Here is 2. We would have an open circle on negative 1, an open circle at 2, but we would shade and include arrows for all the other values of x. So all the shaded region represents elements of the domain, and then interval form of the domain. We do that by describing the 3 intervals here. First, we have negative infinity to negative 1 round bracket, parenthesis round bracket, negative 1 to 2 round bracket, union that together with round bracket 2 to infinity. Those are all 3 different ways to express the same solution. The domain consists of every x value except negative 1 and positive 2.